All right, let's go ahead and look at our little practice test here. We're told to identify the base and the exponent. And what I'm looking at for the first problem is fairly straightforward. We have 5 raised to the 4th power. So let's stop for a minute and think about what this means. So hopefully you understand that 5 raised to the 4th power is going to give me 4 factors of 5. So 5 times 5 times 5 times 5. This right here is just a shorthand notation, right, written in this exponential form to allow us to just save some space, right? And basically when you look at this form here, the bigger number, or the 5, is the number that's involved in this repeated multiplication. It's the number that's being multiplied by itself. This 5 here is the base. I'm just going to write B for base to keep it short. Then you can see that you have 1, you have 2, you have 3, and then you have 4 factors of this base 5, okay? So that's going to be our exponent here, this 4. That's telling me how many factors of this base 5 I have, at least in the case of having a natural number exponent like we have with this 4. So in other words, if I had something like 5 cubed, we know that this is 3 factors of 5. So 5 times 5 times 5. I just take the exponent number of this base, that's how many factors I have. So 5 times 5 times 5. If I had 5 squared, this is 2 factors of 5, okay? So on and so forth. All right, so let's go to the second problem, which is not as straightforward. A lot of people do struggle with this one, so let me take my time and explain this one. For problem 2, you have the negative of 3 to the 6th power, okay? So before we go any further, I want you to type the negative of 3 to the 6th power into your calculator. You're going to get negative 729, and then I want you to do it like this. I want you to wrap it in parentheses, okay? So negative 3 wrapped in parentheses raised to the 6th power, you're going to get positive 729. So I want you to pause for a minute and think about why you get these two different results. Well, in the first case, you're not really raising negative 3 to the 6th power. You could write this as negative 1 multiplied by 3 to the 6th power. So really this is negative 1 times your 3 times 3 times 3 times 3 times 3 times 3, which is negative 1 times 729, which is negative 729. So that's where this result is coming from in your calculator. For the other result, okay, we have negative 3 wrapped in parentheses to the 6th power. Well, this is negative 3 times negative 3 times negative 3 times negative 3 times negative 3, and then lastly times negative 3. We have an even number of negative factors that's going to give you a positive result, so that's positive 729. So that's the difference between the two. It's really important to understand this notation because it's going to come up a lot in algebra and it leads to some very silly mistakes. I can't tell you how many people have argued with about this. You're just like, hey, pull your calculator up and see it for yourself. And then they come back and go, oh, now I understand. Okay, so it's really important to understand this. And what I would just say here is that the base is just going to be the 3. Okay, not the negative 3, but just the 3. So let me circle this so it's the 3 only. And the exponent is obviously the 6 there. Okay, so let's come down to problem number 3. And now you see you have the negative 2 wrapped inside of a set of parentheses. And this is raised to the 5th power. So again, this is negative 2 times negative 2 times negative 2 times negative 2 times negative 2. And this is going to give me negative 32 as a result. Okay, because this guy is odd, the result wouldn't be any different if I did negative 2 raised to the 5th power, but it is actually a different structured problem as you would solve it by saying this is negative 1 times 2 to the 5th power. So this is negative 1 times 32, which is also negative 32. But this is just because this guy is odd, and an odd number of negative factors is still going to be negative. Okay, so negative 32 either way. But the important part here is to say that the base is negative 2. So the base is negative 2, and the exponent is 5. Okay, now let's look at some simplifying problems. So we have negative 3 raised to the 3rd power, or most people say negative 3 cubed. So this is what? It's 3 factors of negative 3. An odd number of negative factors is negative. So now you can just work with the absolute values. What is 3 times 3? That's 9. Then times 3 again is 27. So this is negative 27 as a result. And then coming down to problem number 5, you have negative 2 wrapped inside of a set of parentheses raised to the 6th power. And the quick way to do this is to realize that if this guy is wrapped inside of a set of parentheses, and this is an even number, okay, so 6 is an even number, it's divisible by 2, then we know the result would be positive. And at that point, you could just say, well, what is 2 to the 6th power? Most people know this is 64. Okay, so this is positive 64. Again, if you want to write this out the long way, you can say that negative 2 to the 6th power is negative 2 times 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 negative 2. Okay, and this is going to equal positive 64. Now, again, if you were to see, let me just put this over here. negative 2, so the negative of 2 being raised to the 6th power like this, again, for the reasons I talked about earlier, this is negative 1 times 2 to the 6th power, so you're going to have a sign change here, right? 2 to the 6th power is 64. This is negative 1 times 64, which is negative 64. So I can't stress this enough, the difference between having parentheses wrapped around that negative and not having parentheses wrapped around that negative. Here our answer is 64, but again, if you didn't have parentheses around the negative part, your answer would be negative 64. Okay, let's scroll down. Here we have the negative of 5 to the 4th power. Again, I think we know this at this point. This is negative 1 times 5 to the 4th power. Most of you know 5 to the 4th power is 625. But again, you could write this out. So negative 1 times 5 times 5 times 5 times 5. And then just go through. This would be 625. And negative 1 times that. So negative 1 times 625 is negative 625. Let's look at the 7th problem here. This involves the order of operations. So remember, with the order of operations, you're doing your PEMDAS. That's a good way to remember it. So your P is for parentheses or any grouping symbols. Your E is for exponent operations. Your M and D are multiplication, division. Remember, multiplication does not come before division. Multiplication, division are worked left to right, same level of priority. And then addition and subtraction, again, those are worked left to right, same level of priority. So very important to understand that. So here we have this negative 3 times 5 squared minus the absolute value of 2 squared minus 7, and then times negative 2. So we do actually have grouping symbols here to start. The absolute value bars are grouping symbols. So you want to go inside of there, and you want to reapply your order of operations. So in other words, inside of the absolute value bars, what do I have? I have an exponent operation, I have subtraction, and I have multiplication. So what I'm going to do is the exponent operation first because it has the highest level of priority. So what is 2 squared? That's 4. So basically, I'm just going to recopy everything. So negative 3 times 5 squared minus the absolute value of, the 2 squared would now be 4, and then minus 7, and then times negative 2. Okay, close that down. Now inside of here, you have subtraction and you have multiplication. Multiplication has the higher level of priority. Now, when we work with something like this, you might want to put plus negative there, okay, and do your multiplication like that. So you'd end up with negative 7 times negative 2, which is positive 14. If you don't want to do it that way, you could also multiply 7 times negative 2, which is negative 14. You'll end up with minus a negative, which is plus a positive. Either way, you get the same answer, so it's just a matter of what you're more comfortable with, okay? So I'm going to do this 7 times negative 2, which is negative 14. Let me just replace that in here. So I'll have minus a negative 14, okay? I'm just doing it the long way. Remember, minus a negative is by definition plus a positive, so you can go ahead and change that over, okay? So now I just have this addition left. I'm just going to perform that. So negative 3 times 5 squared, and my handwriting is getting pretty terrible, so let me try to fix that. So negative 3 times 5 squared, and then minus. So inside the absolute value bars, 4 plus 14 is 18. Close that down. The last thing we would do here is just take the absolute value of 18, which of course is just 18. Okay, so that's all that is. So negative 3 times 5 squared minus 18. And now that we don't have any absolute value bars left, we're looking to see what is the highest level of priority. I have an exponent operation, I have multiplication, and I have subtraction. So the exponent operation is the highest level of priority, okay? So what I want to do here is I want to go, we'll have negative 3 times, I have my 5 squared, so that's 25. I'm doing that first, and then minus 18. Okay, so now I have multiplication and I have subtraction. So multiplication has a higher level of priority. Negative 3 times 25 is negative 75. And then we have minus 18 here. And really you could just write this as negative 75 plus a negative 18, okay? So we know the answer is negative because we have the same sign. And then you can just add the absolute value. So what is 75 plus 18? That's 93. So the final answer here would be negative 93. Okay, so that's my answer. All right, let's look at problem number 8 now. So another order of operations problem. So we have this fraction here. In the numerator, we have 15 divided by, you have your negative 3 times 2 wrapped in parentheses, plus you have 3 divided by 2, or you could say 3 halves or 1.5, whatever you want to do there. This is divided by, that's what the fraction bar is telling you. So divided by, in your denominator, you have the absolute value of 6 times negative 4, okay? And then this is divided by negative 12. So when you have fraction bars present, you want to work above and below the fraction bars separately. Okay, so you want to treat them as if they have parentheses around the numerator and parentheses around the denominator. So once you simplify those, you can do the main division. Okay, so I'm just going to work on the numerator first. I'm going to completely ignore the denominator. I'll get to that in a moment. So in the numerator, you have your division, you have your multiplication, you have your addition, okay? But you also notice that you have these parentheses here, okay? So you want to do what's inside of parentheses first. So first I want to do negative 3 times 2, which would give me negative 6. So I would have 15 divided by this negative 6 here, okay? And you can drop the parentheses at this point. It doesn't really matter. And then you would have plus your 3 halves, okay? Your 3 halves. Some people will write that as 1.5. I'm just going to keep it as 3 halves for now, okay? So now what I have is I have division and I have addition. Okay, so what do I want to do first? I want to do division. It's the higher priority. So what is 15 divided by negative 6? Well, it's not going to be evenly divisible. So what I'm going to end up doing is writing this as a fraction. I'm going to write this as negative 15 over 6 like this, okay? And then I can reduce this if I want to. So 15 divided by, I go ahead and say 3 is going to be 5. And then 6 divided by 3 is going to be 2. Okay, so notice that by doing that, I have a common denominator, and now I can perform my last step, which is just the addition of these two fractions. So negative 5 plus 3 would give me negative 2. This would give me negative 2 over the common denominator of 2, and this is just basically negative 2 over 2, which is negative 1. Okay, so the numerator of this fraction is going to end up simplifying to negative 1, and I erased my multiplication symbol there. Didn't mean to do that. So the numerator is negative 1. Okay, or actually, let me write that over here. So negative 1 over. In the denominator, what do we have? It's a little bit simpler. You have these absolute value bars. You have the multiplication. You have the division. Okay, so absolute value bars, we're going to work inside of those first. So basically, you'd have 6 times negative 4. That's negative 24. So the absolute value of negative 24, if we perform that operation, we get positive 24. So basically what you'd have down here is 24 divided by negative 12, which is going to give me negative 2. Okay, so this is negative 2 down here for the denominator. So now what you'd want to do is perform the main division. We know that negative 1 divided by negative 2, well, you could write that as positive 0.5 if you did that on a calculator or something. But really, I'm just going to write it as positive 1/2. Negative over negative is positive. So this will be our answer. Or you could also say it's 0.5 if you wanted to write the answer as a decimal. All right, let's look at problem number 9 now. So another order of operations problem. And another guy with a fraction involved. So we have 5 squared minus 7 times 14 plus 4 cubed divided by 2. This is over, or you could say divided by. You have the absolute value of 6 minus 9 squared, then minus 3 multiplied by the square root of 16, then plus 19. So again, I'm just going to focus on the numerator and denominator separately. We can do the main division at the end. So in the numerator, what you're going to see is that you have an exponent operation, subtraction, multiplication, addition, exponent operation, and division. There are no grouping symbols here. So the highest level of priority would be the exponent operations. So I can just crank those both out. 5 squared is 25 and 4 cubed is 64. Okay, so I'm just going to write 25 minus 7 times 14 plus 64 divided by 2. Okay, so looking at this now, again, I have subtraction, multiplication, addition, and division. So we know that multiplication and division have a higher level of priority than addition or subtraction. But we know that multiplication and division have the same level of priority and they're worked left to right. So I want to do, let me erase this highlighting here. I want to do this problem first because it occurs to the left of this problem, okay? So what I'm going to do is say that 7 times 14 is 98. So this would be 25 minus 98, then plus you have your 64 divided by 2, okay? So the next highest priority here, since this is subtraction and this is addition and this is division, is the division. So 64 divided by 2 is going to be 32. So let's write this as 32, okay? And then from here, we can just do the subtraction and the addition from left to right. So 25 minus 98 is negative 73. So let me write negative 73 plus 32. And then negative 73 plus 32 is going to give me negative 41. Okay, so let me write this up here for the numerator. And now let's just focus on the denominator, and then we can do the main division. Okay, so down here, you'll notice that you have the absolute value bars here. You have subtraction, you have an exponent, you have a minus here, or subtraction. This is really multiplication with these two guys next to each other. So that's an operation. Then you have the square root operation by itself, and then you have the addition. Okay, so what do we want to do first? We always want to work inside of grouping symbols. Absolute value bars are grouping symbols. So I want to start inside and say, what is 6 minus 9 squared? Well, 9 squared gets done first, right? It's got a higher level of priority. 9 squared is 81. So you're basically going to have 6 minus 81, which would give me negative 75. So this is the absolute value of negative 75. And if you take the absolute value of a negative number, it becomes positive, right? So at the end of the day, the result of this right here is positive 75. So let me write positive 75 minus 3 multiplied by the square root of 16, then plus 19. Okay, so in terms of operations, we have minus, we have multiplication, and we have plus. And I forgot about this one. We have this square root operation, okay? So what is the highest level of priority here? Well, it's actually the square root operation. Although we don't mention this usually when we're talking about PEMDAS, when you work with radicals, they occur on the same level of priority as an exponent, so the E step. So this is higher than multiplication or division, so the square root of 16 would just be 4. So I could replace this with 4 here, okay? And then I have this multiplication step, which would be the next highest priority. So this would be 12 here. And now we can just subtract and add from left to right. 75 minus 12 is 63. So let's write 63, then plus 19, which gives us 82. Okay, so let's write 82 there, okay? So let's think about the final answer here and how we're going to get it. We know negative divided by positive is negative. Now you could punch this into a calculator and again get negative 0.5, but really I would just reduce this by saying, okay, well, 41 divided by 41 is 1, okay? And 82 divided by 41 is 2. So again, this is negative 1/2, or you could put negative 0.5 if you wanted to. All right, let's look at our final problem here, problem number 10. So you'll notice that again, we have a fraction. So we have this inside of parentheses, negative of 3 being squared, plus 4 times the negative of 2 being squared. This is over or divided by. You have the absolute value of 3 to the 4th power minus 5 cubed. This is divided by, inside of these parentheses, you have 2 cubed times 11. So again, I'm going to use the same strategy here. I'm just going to go ahead and work the numerator and denominator separately. In the numerator, you have these parentheses here, so you want to work inside first. You have this exponent operation here, and you have addition. Now, you also have this negative out in front. Remember, we've talked about this at the beginning of this practice test, that this is basically the negative of 3 squared, right? So basically it's negative 1 times 3 squared. You do 3 squared first, that's 9. Negative 1 times 9 would be negative 9. So this would end up being negative 9 plus 4 like this. Okay, and I'll put times the negative of 2 squared over here. So this guy right here, negative 9 plus 4 is negative 5. Okay, so basically I have negative 5 multiplied by the negative of 2 squared. So you can break this up and say this is negative 1 times 2 squared like this. And you can do your exponent operation first because it's got the higher level of priority. So this is 4, right? 2 squared is 4. And then you can just multiply through. Negative 5 times negative 1 is 5. And then 5 times 4 is positive 20. So the numerator there is just 20. So again, the important takeaway there is to remember that when the negative is not wrapped inside of a set of parentheses, you will exclude it from your exponent operation. 2 squared is done first, then the negative is applied. 3 squared here is done first, then the negative is applied. Okay, so down here, what do we have? We have these absolute value bars. Those are grouping symbols. We have these parentheses here. Those are grouping symbols. So we can start inside of, let's just go ahead and start inside of this one. And so inside we have this exponent operation here and here. And then we have the subtraction operation. So if I do 3 to the 4th power, that is going to give me 81. So this is 81. And then if I do 5 cubed, that's 125. Okay. So 81 minus 125 is negative 44. Okay, so this is the absolute value of negative 44. Of course, you take the absolute value of a negative number, it becomes positive. So this is simply going to be 44, okay? Then divided by, inside of here, you have this exponent operation, and then you have this multiplication. So 2 cubed is 8, okay? And then 8 times 11 is 88. Now, this is division here. If you do this on a calculator, you're going to get 0.5, but I think it's probably a little bit better, okay? If you did something like 44 over 88 as a fraction, and then we reduce this guy by saying this is divisible by 44 becomes 1. This is divisible by 44, it becomes 2, right? 88 divided by 44 is 2. So this becomes 1/2. So you have 20 divided by 1/2. And we know that when we divide with fractions like this, basically this first guy, I'll write this as 20 over 1, is multiplied by the reciprocal of the second guy, which is 2 over 1. So this gives me a final answer of 40.